Hello, this is Mr. Joseph. I won't be here today, so I just want to make sure to go over your homework with you. So, on number 12, it's asking us to use the given root to find the remaining roots and then write it in factored form. So, one thing that you should notice is if x equals 5 is your root, we need to understand that that comes from the factor x minus 5. And roots come from factors when we set them equal to 0. So for instance, if you do x minus 5 equals 0, I hope that you see we get a 5. So you can either do long division or synthetic division. I'm just going to do synthetic division for time's sake. So I take my root, and then I take my coefficients, drop my first term, and then multiply that by 5. Add going down, and I will get negative 8. Negative 8 times 5 is negative 40. 52 plus negative 40 is 12. 12 times 5 is 60, and we get a 0. Because we started with a power of 3, I know that this will drop down 1 power. And I get x squared minus 8x plus 12. So far I have x minus 5 and x squared minus 8x plus 12. All of this is equivalent to this so far. But our goal was to not only factor it all the way, it was also to find all the roots. So we know one of the roots is already 5. So I'm going to take this and factor. So what two numbers multiply to 12 and add to negative 8? That will be minus 6 and minus 2. So that means that my remaining roots are x equals 6 and x equals 2. So x equals 6 and x equals 2. And then in factored form will be x minus 5, x minus 6, and x minus 2. And that is pretty much how we do these problems. So let's try another one. So we can try 13. I think I'm going to copy and paste it and kind of do it below. Copy and paste. Okay. Once again, x equals negative 6. So I know that x plus 6 is a factor. I'm still going to use synthetic division. Drop the 1. 1 times negative 6, negative 6. Add 6 and negative 6, 0. 0 times negative 6, 0. Negative 11 plus 0, negative 11. Negative 6 times negative 11, 66. And we get 0. I started with a power of 3. So that means it's going to be 1x squared plus 0x minus 11, which means x squared minus 11. So far, we have x plus 6 and x squared minus 11. So this is pretty much factored form. However, because of the fundamental theorem of algebra, I should have 3 roots. So I need to get 2 roots from this. So there's 2 ways to proceed. So I can take this and set it equal to 0. So if I add 11, I get 11. And then I take the square roots, and you get a plus or minus root 11. So our roots will be square root of 11 and negative square root of 11. And if you want to write your answer in factored form, it's x plus 6, x plus root 11, and x minus root 11. And I don't know if you know this by now, but like square roots always come like in pairs. So that's where we're getting that plus and minus. And that's it for this problem. So let's move on to 15. This one is the most challenging one. I wish I was there in class to kind of talk to you about this one, but I'll be okay. So you have x equals root 2, which is just not pleasant to work with. I hope we see that that means that it's x minus root 2. And technically we could use synthetic division and use square roots, but that just gets weird. So what I would recommend, or what I would have you think about is, square roots always come in pairs. So whenever you see a root 2, that means that there's also a negative root 2. So that means that we know another factor, which is x plus root 2. So what we're actually going to do is we're going to take these two and multiply them by each other. It's a little confusing now, but I'll start making a little bit more sense. So once again, square roots always come in pairs, plus and minus. And now we're going to take these two and multiply them by each other. So you're going to get x squared minus x root 2 plus x root 2 minus the square root of 2 times the square root of 2, which is the square root of 4. You get x squared minus 2 from doing all this work. So the cool thing that actually ended up happening is this one is a power of 4. So I know that I'm going to have 4 roots. We already got 2 of these roots, and when we put these two together, it gave us x squared minus 2. The nice thing about x squared minus 2 is now we can actually use long division to divide this. And you'll notice that I used a minus 0x. That just kind of serves as a placeholder as we do long division. So x squared times what gives us x to the 4th? That would be x squared. This x squared is going to multiply everything. So we get x to the 4th plus 0x cubed minus 2x squared, parentheses, with a minus sign. Negative 6x cubed minus 0x cubed remains negative 6x cubed. 3x squared minus 2x squared, that is 5x squared. And then I take the next term and I drop it. Highlight negative 6x cubed, and then look at x squared. So x squared times what gives me negative 6x cubed? That would be a negative 6x. That negative 6x will multiply everything on the outside. Negative 6x cubed plus 0x squared plus 12x. Subtract going down, and we get 5x squared. Everything else cancels, and we drop the minus 10. Then I'm going to put a plus 5, 5x squared minus 10, subtract, and you get 0. So right now we got x squared minus 2 times x squared minus 6x plus 5. This ends up being factorable. So you want to multiply to 5 and then add to negative 6. So you get x minus 5 and then x minus 1. And then from here you get x equals 5, x equals 1. And you already got the plus or minus root 2 from earlier. And if you want to write this final answer as in factored form, it would look like this. Okay, hopefully that was helpful. If you need to go back, slow down a little bit, please take your time in doing that. Thank you.